Okay, good morning. Good morning kasi umaga dito. So, gawa tayo ng video para matapos natin yung syllabus natin kasi wala na namang mga klase-klase because of typhoons and so on and so forth. So, again, I will be discussing from LP6. LP6 is equilibrium. Parang apat in terms of computation, apat yung finukusan ko dito, yung acids, bases, strong at saka weak. So, dalawa yon kasi magkaiba yung way ng pag-compute doon. And then, yung solubility products. You have strong and then you have weak. Strong, yung soluble at saka insoluble. Sa soluble, gagamit lang tayo doon ng solubility table. At saka yung insoluble, gagamit tayo doon ng solubility products table. Yun yung tinatawag na KSP. Kulang sa pansin. So, ilalabo-labo ko lang para makita nyo kung paano atakihin yung problem. Okay? So, una nating problem dito, calculate the hydronium and hydroxide ion concentration and pH. So, parang dalawa, tapos mayroon tayong pH at saka pOH. So, apat yung inihingi. Di ba? Ang ikli lang, pero apat. Pwede ko itong gawing problem, di ba? Okay. So, solution tayo. 0.2 molar sodium hydroxide. So, yung given lang natin is 0.2 molar sodium hydroxide. So, first natin malaman is categorize natin dun sa apat. Ito ay isang strong base. So, strong base siya. So, usually sa acid, base, and water, common si water na reactant. Kaya lang, pag sa base, tingnan nyo, kung si water tulad ng ginagawa natin sa acid, kasi binigyan ko kayo ng example, di ba, ng acid na reaction. Sa base, pwede nyo gawin yan. Sodium hydroxide reacting with your water, that will give you. Pag strong siya, pwedeng isang araw lang. Or usually, isang araw lang pag mga strong acids and strong base. So, isang araw lang, and then you would have your H now will be the acid. Kasi pag acid-base nga, yung isa acid dyan, yung isa base. Kasi base yung binigay, so water will act as an acid. So kung acid siya, magbibigay siya ng H+. So magbibigay siya ng H+, magkukombine dito sa OH, kaya makakagawa ng H2O. Okay? Si OH kasi negative. Tapos, makakagawa ng sodium ion at saka makakagawa, yung matitira dito is OH pa rin, OH negative. So, actually, kung makikita nyo sa book, minsan ito, tinatanggal lang to siya. Kasi nga, common ion siya. Common ion is sa reactant sa product, nandun siya. So, dito natin masabi kung talaga, or pwede nating tanggalin siya sa equation. Usually, yun yung case. Tinatanggal natin siya, kaya makikita nyo sa mga books, pag base na strong, ganito lang yung representation niya. NaOH, tapos diretso ka agad, tapos Na plus, at saka OH negative. Okay? Ganyan. So, ito lang yung natira. Okay? So, pag ganyan siya, mabilis, yung pinakauna nating makukuha sa pH-POH ay ang pH, di ba apat yun na hinihingi? You have pH, POH, tapos meron tayong yung hydroxide concentration at saka yung hydroxyl. So, ito yung apat na hinihingi sa problem. So, mauna nating makuha actually ito, si OH. Kasi nga, sa strong acids and base, ito na 0.2 molar na OH, ito siya ay lahat ng ganito ay magiging lahat ng ganito. Kumbaga, nag-separate siya, pero yung dami niya ay kasing dami rin ng OH. Kaya nga, because strong nga siya. So, pwede natin kagad sabihin na yung OH concentration mo is 0.2. 0.2 mole per liter. At galing dyan, pwede mo na kagad makompute yung pOH to be the negative log of 0.2, which is negative log of 0.2, negative log of 0.2 is actually 0.699. So, 0.699, ayun, 0.699, period. Kasi POH yan. So, check na ito, dalawa. Next natin na makukuha, pwede tayong mag-pH actually. Pwede rin mag-H3O. Mag-H3O na lang ako kasi may paliwanag dyan para mabilis na yung paliwanag. Actually, meron tayong tinatawag na sa water kasi, meron tayong tinatawag na KW. Constant yan siya. I think mababasa nyo yan dun sa reading na binigay ko. So, I think you will see that in the reading materials that I've given you. Maybe I have to speak in English. So, KW actually is 1.00 times 10 to the negative 14. This is also the reason why you have a neutral pH which is 7. Why? Because this is also the product of your OH and your OH and your hydroxyl H3O plus, your acids and base. Kasi nga neutral to sila, so pwedeng ito siya mag-equal sila. So kung mag-equal sila, you can compute, pwede mo to siyang palitan ng H3O plus. H3O plus and then H3O plus. Then you have H3O plus squared. Okay? 1.00 times 10 to the negative 14. Walang unit, yung sila yung mga K. So, kung square root mo to siya, square root, so makukuha mo yung H3O plus concentration, which is the square root of 1 exponent negative 14. You will have 1 times 10 to the negative 7. Now, pag kukunin mo yung pH niyan, yung pH niyan is negative log of 1.0 times 10 to the negative 7. Ayun na magkakaroon ng pH na 7. Kaya yun talaga yung pH ng neutral, which is 7. Kasi yung hydroxyl at saka hydroxide concentration mo with the kW of water, which is 1.00 times 10 to the negative 14 is 7. Kaya pag acid-base tapos may water na nasa water siya, usually magagamit mo tong equation na to. At saka also, yung pH at saka POH, meron pang isa niyan. I mean, from this also, alam natin na yung pH, kasi yung KW, pag kinuha mo yung negative log, is 14 yan. Kaya ibig sabihin yung pH at saka POH is mag-equal yan ng 14. So, pwede nating unang kunin yung ano yung gusto mong kunin. Kunin muna natin yung pH. So, galing dito, pangatlong answer, yung pH actually is 14 galing sa equation na to. Again, yung equation na to, pwede mo itong mabasa dun sa, sorry. You can also read this from the reading material that I've sent you. pH would now be equal to 14 minus the POH. And then your POH is already computed. So 14 minus 0.699, and that would give you 13.3 as a pH. So 13.3. So this is really basic. Basic is base. Mapait siya actually. Mataas to na base actually, pH. Pag madampi ito sa mga kamay nyo, yung effect ng base, hindi masyado kaysa sa acid. Yung acid kasi pag mataas siya masyado, tapos nilagay mo sa, o nalagyan ka nun, medyo masusunog ka. Dun sa base, medyo matutuklap yung panit mo sa katagalan. Kasi common to siya sa pagwawash ng mga um, container ng mga food materials like the beverages. Kasi nagtrabaho rin ako sa mga beverages. Common to siya na panglinis yung strong base ng itong na sodium hydroxide, NaOH. So Makati siya actually, Makati. Kaya lang ito na mataas, of course, at sa katagalan medyo matutuklap yung, anyway, matagal naman kaysa sa acid. Kasi sunog ka kaagad talaga. So 13.3. So, check na tayo sa pH. Actually, you can also compute H3O plus, itong equation na to. Ito. So, you have OH at saka H3O plus, which is equal to 1.00 times 10 to the negative 14. So, hindi na magkapareho yung OH at saka H3O. So, you can substitute the 0.2. So, H3O plus would be equal to 1.00 times 10 to the negative 14 all over 0.2. So, mag-equal to siya, all over OH muna, all over OH negative concentration. Then, substitute tayo, 1.00 times 10 to the negative 14 divided by 0.2. Then, you will have 1 exponent negative 14 divided by 0.2, and that will give you 5. 5 times 10 to the negative 14. So, ito yan yung H3O concentration mo, and then probably we can check yung pH mo is negative log of 5 times 10 to the negative 14. Negative log of that, you will have 13.3. So, makikita mo, nag-check siya. 13.3 dito. Okay, so tingnan nyo na lang. So, yun yung pag strong acid, strong base. Direct yung computation niya. Binigyan ko na rin kayo ng HCl na example nun. Okay? So, yun. So, you only have to categorize strong acid, strong base, strong electrolyte, or soluble, tapos insoluble. Okay, thank you. Putul-putulin ko lang para maikli.